Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here, coming back with another fantastic chemistry video, and today we're going to convert some skeletal formulas into expanded formulas. No problem. Now, we've got some interesting molecules to deal with today. Well, let's get into it. Remember, in a skeletal formula, wherever lines terminate, that is a carbon atom. Wherever two or more lines come together, that is a carbon atom. Hydrogens and carbons are never drawn. They're assumed. The hydrogens bonded to the carbons are never drawn. If hydrogens are bonded to something else, they're always drawn. So let's do it. So now let's see here. So here is a line terminating. Here's a line terminating. Here's a line terminating. So these must be two carbon. Here are two or more lines coming together, so there's a carbon right there as well. Two or more lines coming together, so there's two or more lines coming together, so there's a carbon here. And two or more lines there, so there's a carbon there. Now remember, carbon has to have 4 bonds, and if there's nothing else drawn, it must be the hydrogen. So this one has 1, 2, 3. Another bond, so that's 4. This one has 1, 2, 3, 4. So this particular carbon doesn't get any hydrogens at all because it already has 4 bonds. So that happens. Don't let that faze you. Just move on. This carbon has 1, has to have 4, so it must have 3 bonds, each one to hydrogen. Here, 1, 2, 3. It's got 1 bond to hydrogen, 3 bonds to hydrogen. Good, good. This one must have 3 bonds to hydrogen. So let me draw that again, if you want. There we go. There's the double bond. There's the bromine. There's the hydrogen. There's that carbon with the hydrogen there. That's a lot. Now, I think everyone will agree this is getting a little busy. Nobody wants to really look at that. The skeletal formula before I messed it up was much more pleasant to look at. Okay, but this is indeed correct. Let me make that bromine just a little nicer. Okay, now, this one. Remember, wherever lines terminate, that's a carbon. 2 or more lines come together, that's a carbon. So there's a carbon here, a carbon here, a carbon here, and a carbon here. But not here, that's an oxygen. Carbon, 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 carbon. Carbon has to have 4 bonds. Now this carbon has 4. 1, 2, 3, 4. This carbon, 1, 2, 3, has to have 1 more. This carbon, 1, 2, 3, 4. Don't put any hydrogens on this carbon. It already has an octet. This carbon, 1 bond, has to have 3 more. And there you go. There you have it. If you want to see it drawn out a little more neatly, there you go. So this and the skeletal formula that was under there are the same molecule. I think everyone will agree the original skeletal formula is much nicer to look at. But you have to know what they mean, and the only way we can tell that you know what they mean is to have you draw the skeletal back to the expanded. So that's a common question on organic chemistry exams. Be prepared for it. All right? So now, guys, I hope you liked this video. If you did, slap that like button. Leave me a comment below. Let me know how I'm doing. Let me know the kind of questions that you're working on in your organic chemistry class so that maybe I can help you too. And if you could, please share my content out with your friends. Let your friends know that I'm around. Maybe I can help them in their organic chemistry endeavors as well. And if you could, subscribe to my YouTube channel. It really does help out content creators. When people subscribe, it lets YouTube know that our videos are good and that you guys are engaging with them. It also keeps me as a creator personally very motivated to keep making more and more videos for you guys so that you guys can do better in your chemistry classes. Now with that, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.